Hello dear students, welcome to my channel Kaveri Science Tutorials. Today we are going to see a very important 8th standard chapter, that is sound. So how the sound is produced, okay? How the sound is produced and basic principles behind how the sound is produced is the vibration. तुम्हाला माहिती आहे का, मॉस्किटोला म्हणजे डासाला आवाज असतो का? नाही, पण आपण डास जवळ आला की आपल्याला काय ऐकू येतं? गुई गु असा आवाज आपल्याला ऐकू येतो. तर तो जो हमिंग साऊंड ऑफ द मॉस्किटो इज ड्यू टू द व्हायब्रेशन ऑफ द विंग्स ऑफ द मॉस्किटो. अख्खा चॅप्टर, पूर्ण चॅप्टर एवढंच लक्षात ठेवायचं आहे की व्हायब्रेशनमुळं हा साऊंड प्रोड्यूस होत आहे. मग ते व्हायब्रेशन आपल्या घशातल्या व्होकल कॉर्डचा असू दे किंवा एखाद्या म्युझिकल इन्स्ट्रुमेंटमध्ये एखाद्या इन्स्ट्रुमेंट जसं काही गिटार आहे त्याच्या स्ट्रिंगचं व्हायब्रेशन्स असू दे. सो एनी व्हायब्रेशन प्रोड्युसेस साऊंड. सो बिहाइंड प्रोडक्शन ऑफ साऊंड देअर इज अ प्रोडक्शन ऑफ व्हायब्रेशन्स. मग ते व्हायब्रेशन्स एअर पार्टिकल्समध्ये पास होतं, त्याची साऊंड वेव्ह तयार होते अँड ड्यू टू दॅट साऊंड वेव्ह रिचेस टू आवर इयर अँड वी कॅन द सिग्नल गोज टू द ब्रेन अँड वी कॅन हिअर द साऊंड. तर अख्खा चॅप्टर एक लक्षात ठेवायचं आहे की साऊंड इज प्रोड्यूस ड्यू टू व्हायब्रेशन. आता द स्टार्ट ऑफ द चॅप्टर इज फ्रॉम ट्युनिंग फोर्क. ट्युनिंग फोर्कची डायग्राम टेक्स्टबुकमध्ये दिलेली आहे. एक असा सॉलिड हे असतं, पूर्ण भरीव असा मेटलचा एक इन्स्ट्रुमेंट आहे अँड इट हॅज अ स्टेम. सो दिस इज द स्टेम ऑफ द ट्युनिंग फोर्क अँड दीज आर द टू प्रॉंग्स ऑफ द ट्युनिंग फोर्क. एकदम भरीव स्क्वेअर शेपमध्ये ह्याच्या भरीव असा एक इन्स्ट्रुमेंट आहे. कदाचित तुम्हाला स्कूलमध्ये दाखवलं असेल. सो दिस इज द स्ट्रक्चर ऑफ ट्युनिंग फोर्क. सो व्हेन वी hold the stem of the tuning fork in our hand and we are vibrating the tuning fork, the prongs of the tuning fork, they move forward and backward direction. Due to this movement of the vibration of the tuning fork, the forward and backward movement of the tuning prongs takes place. So these are the prongs and this is the stem of the tuning fork. ह्या prongs ची movement होते फॉरवर्ड डायरेक्शन ला झाली आहे, ही बॅकवर्ड डायरेक्शन ला. So due to this, the air particles, suppose we are showing the air particles in my air मध्ये काय असतं, different gases are there, different dust particles are there. So these all togetherly called as air particles. So air particles, air molecules are shown by the vertical lines. Air particles or air molecules are shown by the vertical lines. Now when the prongs of the tuning fork they move in the forward direction, the air molecules they come close to each other and their density increases. Density and pressure increases. Density and pressure in this region increases. कशाच्या? air particles density increases means एवढ्या जागेमध्ये हे particles होते, बाहेरच्या फॉरवर्ड डायरेक्शनला मुवमेंट झाल्यामुळे हे त्या जागेमध्ये काय होतात, कॉम्प्रेस होतात, त्याच्यावरती प्रेशर जनरेट होतं आणि ड्यू टू दॅट प्रेशर दॅट रिजन प्रोड्यूस्ड इज कॉल्ड ॲज डिनोटेड बाय सी अँड इट इज कॉल्ड ॲज कॉम्प्रेशन. अँड द रिजन ड्यू टू द बॅकवर्ड मुवमेंट ऑफ द सो कॉम्प्रेशनची डेफिनेशन अजून एकदा. The region of the air molecules where the pressure and density of the air molecules is high. The region where the density and pressure of the air molecules is high is called as compression. The region of air molecules where the density and pressure are high, of the air molecules are high, the high density and high pressure, that is called as region of compression. Again, where the region where the density of the air molecules is less density and less pressure, that region is called as means it is the region of rarefaction, and it is denoted by the R. So this region is called as compression and this region is called as rarefaction. Again, these total region we can say this all the where the air molecules are away from each other, they are not closely packed, that is called as that is called as rarefaction. Again, the prongs of the tuning fork, they are in backward direction, and in this way there is a space is generated for this region to move ahead. So to propagate means to move forward. Propagate means to move forward, and the compression region moves forward, and there is a region of rarefaction is created due to the backward movement of the prongs of the tuning. So why we are going to understand the meaning of compression and rarefaction. We have seen the definition. कोणताही एक पार्टिकल, कोणताही एक सबस्टन्स घ्या, ज्यावेळेस त्याला तुम्ही प्रेस करता त्यावेळेस आता समजा मड आहे तुमच्याकडे, चिखलाचा गोळा आहे, त्याला तुम्ही प्रेस करायचा. प्रेस केल्यानंतर तो पार्ट असा वरती येतो. दॅट पार्ट इज कॉल्ड ॲज क्रेस्ट फॉर्मेशन, लाईक असं वरती येणार ते. तर ते जे आहे इट इज ड्यू टू प्रेशर given by us and due to the high density of the particle in the small region. So the particles are densely packed and pressure is high, so that region of the mud particle is called as compression. Here also in sound waves, due to vibration of the tuning fork, what happens, the compression on the air particles takes place, and that region is called as region of compression. So due to progression of the propagation through the air, the compression is propagated by the air particles, and the next region is rarefaction. The region of reduced density and pressure of the air particles is called as rarefaction. Okay, so mud particles, mud ज्याप्रमाणे आपण वरती प्रेस केल्यानंतर वरती क्रेस्ट तयार होईल, तसंच similar thing occurs with the air particles, and they become crest-like structure from compression and reduced structure from rarefaction. In this way, one cycle of compression and rarefaction forms one sound wave. आता इथून पूर्ण ही कंप्लीट काय म्हणणार, एक साउंड वेव. ठीक आहे. So this is one sound wave. One cycle of compression and rarefaction is called as one sound wave. Second important definition of sound wave: one cycle of compression and rarefaction forms one sound wave. Next definition आहे frequency. त्यातच आपण ऍड करतोय frequency. So what is frequency? The number of such cycles of sound waves produced in 1 second in any medium is called as frequency of the sound wave. Number of cycles of sound waves produced in 1 second in any medium is called as frequency of the sound waves. Vibration create झाले, compression rarefaction propagate होणार एअरच्या थ्रू, आणि sound waves create होणार. Sound waves reach to our ear, and our eardrum vibrates and we hear the sound. Sensation goes to the brain and we hear the sound. In this way, propagation of the sound takes place through the air. Now we have to prove in the next part, that is why medium is necessary for the propagation of the sound. The sound wave. So why there is a necessity of the medium, like any medium may be there. The medium is necessary, like air. Air is a medium to propagate the sounds. Means to forward movement of the sound takes place due to the presence of the air particles. So they carry air particles, and there we have seen there is a region from compression rarefaction, and they pass the sound waves ahead. So there is necessity of the air as a medium for the propagation of the sound waves. This experiment proves there is a necessity of the sound waves. How? So this is a bell jar, and in that bell jar electric bell is placed like this. Total container is closed structure, and the wires are connected to the switch to switch off and switch on the electricity through the bell. So these are the wires. Electric bell is in that bell jar. All the containers are closed, and vacuum pipe is connected at the bottom of the bell jar to create the vacuum, means to remove all the air from the bell. So at the start of the experiment, there is a air is present, and vacuum pipe air pump is off, switch off, and the air is present inside the bell jar. So when we switch on the button of that, means electric switch of that electric bell, when we switch on the key, the electric bell rings, and we can hear the sound outside the bell jar, due to there is a presence of air, and we can hear the sound due to that air. But when we start the vacuum pump, slowly the vacuum pump starts to remove air from the bell jar. As the air present inside that bell jar decreases, quantity of air, amount of air inside the bell jar decreases, the sound of that electric bell reduces. And one stage comes at that stage when all air is removed by the vacuum pump, the sound cannot be heard, or very low sound can be heard from the electric bell. So that is, this experiment proves that when there is a removal of air takes place through the vacuum pump, the sound of the electric bell decreases. It shows that there is a necessity of air, or there is a necessity of medium like air for the propagation of the sound. Okay, so this is this question is very important question from this chapter, and this is asked for give reasons, or why medium is necessary for the propagation of the sound wave. So this is the reason, and in this way this experiment proves that there is a necessity of air as a medium for the propagation of the sound. Thank you.